Look at the two cups on the table. What did you see here? What did you see here? These two cups.
Water at the same height and two glasses.
Okay, so I'm going to put one of this. What is this?
Ice.
Okay, I'm going to put one of the ice cube into this cup. What do you think will happen? What do you think? What do you think will happen to this you say it's water, right? So what do you think will happen? What do you think will happen? If I put it in,
Colder.
okay, beside getting colder, what do you think it will happen to this ice cube?
The ice cube will melt because the ice cube is cold. So when it gets in the water like warms it up. But actually, even though first the water tries to warm it up, then the ice melts.
Okay.
The cold spreads
So
all
you
over
think
the
that
water,
water
and then if you put more heat on the ice, it will melt back into cold water.
Okay, you think that this cup will get cold and then the ice will melt. What else? Yeah, what else? What else will happen if I put this ice cube? What else will happen if I put ice cube into this? You say it will get cold, the ice will melt, and what else? Anything else? Anything else?
Well, this white will turn into transparent on the sides.
Okay, so so I want you to observe the cup, okay? Observe the level of the liquid. What do you think? Look at the level.
A little bit higher.
Exactly. So the water level actually goes up. And then what else did you observe? What else did you observe about the
ice cube floats?
Right, the ice cube floats. Okay. And what else did you observe? What else?
I observed that when it floats, part of it's sticking out of the water, and some of it looks like it's not.
Okay,
And
now.
just now,
Okay.
a while ago, I saw it was bumpy so it sticked on top of the water, but now it looks like it's flat below the water. Just like a thin layer like this much.
Right, okay. So now I'm going to put this ice cube into this second cup. So I'm trying to try the game with this cup. What do you think will happen this time? What do you think will happen this time?
It will rise like this one and do the same thing.
It will rise. What else?
Because there were ice cubes and...
Okay, what else?
Everything that happened to this one might happen to this one too.
Oh, everything that might happen to this one might happen to this one. So this, it floats, the ice is melting, the water get cold, and then the water rise up. So you think it will exactly the same? Okay, let's try. Oh, what is happening?
That means that one's heavier.
Oh? So what happened to the ice? What happened to the ice, actually? What happened to the ice? So what is
It's bigger than this one.
What is the possible conclusion can we make from this observation? You see, this ice, it float. And then this piece of ice...
The little ice will float and the other ice will sink.
Are you sure? I can put a big piece of ice here. I can put a bigger piece. You think this one will sink because it's bigger piece? You think this one will sink because of a bigger piece? This is bigger piece, right? Oops. So you think you put a smaller piece, this one will sink?
Wait a second.
Or float? You think a smaller piece, in this cup, it will float?
I think so.
Oh, it still sink.
Wait a second.
So what is the conclusion? What is the conclusion?
Wait,
so
I think you might have dropped it high, so the
it doesn't matter. It doesn't matter. It doesn't matter. Drop it too high. You think it will float like this one? You think
yes.
You think there's a difference?
No.
Yeah. So now I want you to look at the first conclusion that the two ice cubes. Do you think that the two ice cubes are different? That's why this one float, this one sink. You think so? You think so? Oh. Now I can switch. Now can I take out this and I switch? You think that this one will? Okay. Then if that's the case, I put this here.
Wait.
I put this here. It's still sink right here. So what do you think?
Second, you
Now-
put something in this water.
So can I check? Okay, again.
What if
The
something in
eyes,
water?
are the eyes the same? Is it the same eyes?
Every
So
ice is the same.
if the eyes are the same, what is different? What is different? If the eyes are the same, what is different? So what is happening here? So what is
There's-
happening here? The first cup and the second cup, what is happening here? What is different?
Well,
What is
the thing
different?
That's different about the water is this
Oh.
is clear, and this has really, really tiny gas bubbles, which I don't know why.
But in the first place, when we look at it, it's
gas.
it's the
There's
the
gas
same,
in
right,
there.
Ethan?
There's both.
Now listen. In the first place, before we did the experiment, you look at it, it's exactly the same cup, right? You look at it, they are the same, right? So now you tell me that now the liquid is different. So why is that so? Can you tell me? So what did you conclude that? What did you conclude? So you think that the liquid is different, right? How could
I
that
think
be?
Something might have.
So what is happening here? Can you tell me what is happening here?
Something was put in here.
Okay, so which means that are you telling me that this liquid is different from this liquid?
Yeah, but there
I
was
need you-
water.
Yeah. How do you know that this is water? You think that you tell me that it is different, and now that you say that both
First
are water.
First, I see that both are water, but now when you put the ice cube in,
Okay.
there's something, a difference in here.
Okay. So I need you to tell me. I want you to take a look at this.
Tell me what.
You smell it. What is different?
Smell it.
Yes, smell this one. So what is different?
It's like salt. Wait, did you put salt in here?
So how does that smell?
This one smells awful, like doctor medication.
Okay.
The wiping thing, that Lala thing, smells gross.
That
This
smells
one's less. It still smells like
So-
medication, but less.
So now,
And
can you guess which one is water? Which one is water?
this one
This one is water. Why? Why do you think this one is water? This cup is water.
has no smell.
It has no smell. Water doesn't have
Yes.
smell. What about this one? Do you think it's water?
It might be doctor medication mints.
Okay. So can you tell me? Can you tell me now that you know the two liquids are different? I'm going to tell you this is the rubbing alcohol. This is alcohol. This is alcohol. Now that you know that both liquids are different, what can you
And how come
conclude?
it looks like the same at the first time?
I know. Some liquids look the same, so they can be deceiving. Right? So how can you conclude, Ethan? So why is it this on the water? Can you tell me? On the water, where are you going? No. On the water, you see. Now we roll back again. On water, the ice float.
Yeah, but the
On the alcohol, what happened to the ice?
it sinks.
What does that show? What does that show? Tell me.
Yeah.
What does that show about
That means
the
alcohol will
liquid?
make more pressure in the water that pushes the ice down.
It has pressure in the water? Do you think it has pressure in the water? The ice is still floating in the water.
What?
So what does that
What?
tell you about? Now what happened, Ethan?
What are you
Ethan,
talking about?
now Ethan, I need you
Are you
I,
sure
I
it's
need you to
floating?
I need you to pay attention. Here, I'm asking you a question. Now, what does it make? What is it that make this ice sink? What is it that make this ice sink?
That funny little smell.
The smell? Because it is not water, right? Ice float on water. And when it comes to alcohol, it sink. Why do you think that
Maybe
happens?
the alcohol. Well, maybe it takes all the air out of the. Because alcohol is supposed to be gassy, right? Most alcohols are.
And then why does
And
that
they take
happen?
out- and they try to.
And look, observe the eyes. What is happening now?
Well, there's bubble coming out,
Okay.
And it might be because the alcohol is making the ice into alcohol ice. And then taking all the gas from the ice.
Oh, really?
Yeah, it looks like
So-
bubbles.
So what does that mean? What does that mean? That
Means
will
ice only floats on water, not alcohol.
ice float on water and not on alcohol. And the next lesson, I will kind of tell you what happened. Okay? And it has got to do with density. Yeah, it has got to do with density. So we will look into that in our next experiment, okay? Okay, so what did you learn from here? What did you learn from here,
I
Ethan?
learned that ice only floats on water. Alcohol, it will sink.
Really? Is in this Ethan,
Let's
in
try to
this
smell
experiment, Ethan, in this
Hey,
experiment
now the
we
ice
are
is poisoned.
now listen, Ethan, in this experiment we are dealing with only two liquids, water and alcohol, the rubbing alcohol. So you think that ice will float on water? Does it? What about oil? Do you think ice will float on oil?
This one is poisoned with.
No,
this
because
thing
we
too.
switch. Because we put the ice from here and put it
come
here,
it's not
right?
floating?
Now, Ethan, listen. I need you to pay attention. Ethan, are you listening? What do you think? If I change the liquid into oil, do you think that ice will float on oil? What do you think?
Yes.
You think ice will float on
Yeah, can
oil?
we try it now?
Okay, we will try it. We will try it. Okay, so now in this experiment, we say that
We see
ice
that-
floats on water and not on alcohol.
And
Okay,
now-
right?
And now.
And then we will learn about the density of the liquid and about density. Okay. So are we done?
I guess I'm ill.
Okay.